In this video, we again need to determine some quadratic function to model a situation given in a word problem. So this time, please pause the video and read the word problem. Having read the word problem, we can see that this is a situation where we're looking for the maximum area of, in this case, 3 rectangular regions to house livestock that have been constructed off a barn. So it's always good to draw a diagram in a situation like this. So I've got my barn here. Now I've got the 3 pens that are going to hold the livestock. Now I know I've got a width and a length in my diagram, but you have to be careful because when we're using our 240 meters of fencing that we talk about up here, I've got to construct really 4 widths and 1 length using that 240 meters. So when I need to develop a quadratic function that models the area of the pen, I'm going to use 2 formulas. I'm going to use one that relates the total length of fencing that I have to the 4 widths and 1 length, as well as a formula that relates the length and the width using area. Now, using this formula, I can rewrite and find out that if I knew the width, I would just need to subtract 4 of those from 240 to get the length. Meaning that I can then substitute in from here to here and get a quadratic. Because now I know that the area is equal to 240 minus 4w times w, which, doing some multiplication, gives me negative 4w squared plus 240w. So there's my quadratic function for modeling in part A. Now in part B, it says determine the maximum area of the pen and state the dimensions. Well, to determine the maximum area, again, I'm going to be using the vertex. So I'm going to be using negative b over 2a. Looking back up here, I can see I've got an a value, I got a b value. So plugging those in down below, I get negative 240 divided by 2 times negative 4, which is negative 8, which gives me a value of positive 30. So when I want to find the maximum area of the pen and state the dimensions, I know it's going to occur when I have a value of 30. Now I did use x here, but it should be noted that the value that I'm using in the equation here is w, meaning this represents a value of w equaling 30. Okay? So if I want to find the maximum area, I need to plug in the 30 into here. So I have the area equals 240 minus 4 times 30 times 30, which gives me 240 minus 120 times 30, or 120 times 30, for an area of 3,600 meters squared. And the dimensions, I can use my formula up here to get. I know my width is 30 meters, and I know that the length, using this expression here, length times width, my length is 120 meters.